The first 9 problems on this practice test are matching, and there may be some answers that you could use more than one place. The problem we would run into by doing that, if we don't put them in the place that fits the best, is that you might have more questions and not enough answers, because you might be left with an item that doesn't have an answer that really fits it very well. So we'll give you the best answers on each of these. Angle 1 and 4, what are they to each other? So you have to locate these angles. So here's 1 and here's 4. And that's the prime definition or example of vertical angles. So that would be letter A, number 1A. I think I might not even try to write these in here because it's so small on my screen that if I tried to write an A next to the number 1, it probably wouldn't fit. I'll give it a try. A. 4 and 8. So we're looking at 4 and 8 here. And if you slid line B right up on top of line A, they would overlap their corresponding angles. So that's E. Line A and line B are parallel to each other, and that's choice C. Line C is a transversal, H. Angles 5 and 6, so we're trying to find them 5 and 6 here. And together they make 180 degrees, so they're supplementary, but you notice that supplementary is not one of the choices. So we have to go with linear pair. And they are a linear pair. A linear pair have to be adjacent to each other, and indeed these are, so that's F, linear pair. You see why I didn't want to write it in there? That's an F. That's the best I can do. Number 6, angle 7 and angle 2. 7 and 2. They're both on the outside of the parallel line, so they're exterior, and they're on alternate sides, so those are alternate exterior angles. Choice I. Nice. 3 and 6. Interior, and they're alternate, so they are alternate interior angles. G. Angle 4, look at the side, look at what's left, is acute and obtuse. And it actually shouldn't be an S on letter B, it should be acute angle, not acute angles. So angle 4 is acute, best choice is B. And angle 6 is the obtuse angle, choice D. In the given triangle, angle 1, 2, and 3, 4, and 5, the one angle that's not labeled is 100 degrees. So here we have a 100 degree angle right here. And the 100 degree angle and angle 3 are supplementary. So we'd think, what do we add to 100 to get 180? And that would be 80 degrees. So angle 3 is 80 degrees. We know that angle 4 and 5 are part of an isosceles triangle because this indicates these two sides are the same length, which means angle 5 and angle 4 have to be the same measure. This angle occupies 100 of the 180 degrees. 5 and 4 occupy the remaining 80, and they're the same size. So they're half of 80. So angle 5 must be 40 degrees, as is angle 4, 40 degrees. So now we know that angle 3 is 80 degrees, and angle 1 and angle 2 are equal or congruent to each other. So in this triangle, which is not similar to this other triangle, they're both isosceles triangles. So this is an isosceles triangle, which means angle 1 and angle 2 are congruent. Angle 3 takes up 80 degrees of the 180 degrees of the triangle. So angle 1 and angle 2 are left to evenly split 100 degrees. Together they make 100, plus this 80 makes 180. So angle 1 and 2 are each half of 100, or 50 degrees. So now we have all the angles. And we just go to the questions. Angle 5, we figured was 40 degrees. Angle 2 was 50 degrees. And angle 1 is also 50 degrees. So then we have the classic set of parallel lines with the transversal creates 8 or more. You could see more than 8 angles here, but there are typically, you think about 8 of them, and they come in pairs. One of them is 110 degrees, and there will only be one other measure here, the supplement of 110, which is 70 degrees. So everything is either 110 degrees or 70 degrees. When I say supplement, we're talking about 2 angles that add up to 180 degrees, such as this 110 degree angle and angle 6. They clearly make a straight angle, so angle 6 has to be 70 degrees. I'll circle that to keep it apart from the 6th. And angle 7 is also 70 degrees. Let me change colors here, that'll make it a little plainer. So angle 5 is 110 degrees. Angle 4 is 110, 70, 110. I'll trace over this, 70, 70. So now you have them all, and you can, oh, miss this one, 70. You can just fill in the answers. Angle 1, 110. Don't forget to hit the degree symbol. Angle 2, 70 degrees. Angle 3, 70 degrees. Angle 4, 110. And angle 5, another 110. So when you do these, I would strongly urge you to fill in everything in the diagram and then just look at it, find the angles as it's listed, write the number and the degree symbol. This is a diagram of a typical, it looks like an hourglass problem where you have 2 triangles and they have an angle that is created by the intersection of 2 of the segments, which creates vertical angles here and here. So we could just put in here that these 2 angles are the same size. And since we now have this angle matching this angle, we don't know the degrees, but we don't have to, and this angle matches this angle, we know that the third angles must also match. So this angle down here in the corner has to match the angle up here in this corner, which proves these triangles are similar by angle, angle, angle. They're clearly not congruent because this side corresponds to this side, and 15 and 20 are not the same size. And this is the S. It looks like a 5, but it is actually side S. I don't like the S's, but that's typically what's used in this kind of problem. We know that corresponding parts of similar triangles form proportions. S is opposite the single arc, and opposite the single arc in the smaller triangle is a 12. So we can write the proportion S to 12. I should say that's a ratio. The proportion is going to come when we fill in this part. And we can pick, so we picked S from this triangle, so we can pick the 20, which is the only choice we have. We took S here in the top numerator, we have to pick the 20 and write 20 over the part that it corresponds to, which is opposite the double arc. And opposite double arc, we have a 15. Using cross products, we can say that 15S equals 12 times 20. Divide both sides by 15. That'll leave us S. And we can do 12 times 20 is 240 and divide by 15 to find the answer. But I'm going to reduce before I multiply. I see that 5 goes into 20 4 times. 5 goes into 15 3 times. 3 goes into 3 1 time. And 3 goes into 12 4 times. So we're really left with 4 times 4, which is 16. So the value of S is 16. Number 19 is a lot like number 18 was. We have the angles that kind of flip over here, the vertical angles, so they're congruent. And the strategy now is the same. Since we have congruent and congruent, 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 And these three angles add up to 180. These three angles add up to 180. By logical reasoning, we can conclude that these angles are congruent to each other, the triple arc angles. And opposite the double arc, we have a 9, and opposite the double arc, we have a 9, which is proof by angle, side, angle, angle, side, angle, that these triangles are exactly the same. They're not similar. They are congruent triangles. So this becomes an easy problem with no calculation. Side S is opposite the single arc. So we go over to this triangle and see opposite the single arc is a 7. So S would equal 7 feet. This little symbol stands for feet, 7 feet. This problem is similar to number 19. These two triangles have a common angle, which is right here. So we can just go ahead and put an arc through it. And since we have a common angle here, and also here, we know that these two angles match up. So we can put the 3 arcs through them. And that's going to help us identify corresponding parts. We'll start by using S compared to its corresponding part. And what corresponds to S? Well, it's opposite the double arc angle, and opposite the double arc angle is a 14. So S compares to 14. Now I have to pick a part from the larger triangle, and the only part I know, the only length I really know is the 40. So I have to say over 40 over the part that corresponds to 14. I'm sorry. We're going to say that 40 corresponds to the 16. So we're going to put over 16. Then when we cross multiply, we'll end up with 16s equals 14 times 40. Divide both sides by 16, that'll cancel. The largest number that goes into 40 and 16 is an 8, so I'm going to use that. 8 goes into 45 times, into 16 twice. 2 goes into 2 once, and into 14 7 times, so S will equal the product of 7 and 5, which is 35. And our given unit is feet, so we'll put the feet there. S equals 35 feet. And it's reasonable if you look at it. 16 is more than 14, 40 is more than 35 in the same proportion. So this one we're asked to find angle A. There's no S in this, and we actually can't tell the side lengths from what we're given in this. We know they're similar triangles, and we see that these sides are the same compared to each other. So this is an isosceles triangle. This is also an isosceles triangle. The two congruent sides come together to make a 50-degree angle. So we know that this angle would be 50 degrees. We also know that these, because it's an isosceles triangle, these angles are congruent to each other. So of the 180 degrees in the triangle, we've taken up 50 of them with this angle, leaving 130 degrees to be split evenly between angle A and its partner over here. But these two angles are exactly the same, so if we find half of 130, we'll have the answer that we're looking for, which is 65 degrees. So angle A, the measure of angle A is 65 degrees. So we have a shape, and we're supposed to circle the letter of the name that does apply to the figure, which means logically there's probably one thing that applies and 3 that do not apply. And you go by what you're given here, which we know that the opposite sides are congruent, and there's right angles here and here. So you can figure out that if these are right angles, these other two have to be right angles. So we know right angle here and right angle here. If you're told that this side and this side match up and this, you can assume that these two are not the same. So in a square, all sides have to be the same. It can't be a square. A rhombus is a quadrilateral that has all sides congruent, so it can't be a rhombus. A trapezoid, we know that if you can think about it logically, these sides, opposite sides, have to be parallel because of the right angles. So that eliminates isosceles trapezoid, because trapezoids only have one pair of parallel sides, and we have this and this, that's one pair, but also a second pair of parallel sides. So if it's not a square, a rhombus, or an isosceles triangle, it is indeed what it looks like, a rectangle. In number 24, we're asked to find the area of a circle. His radius is 12 inches. So our radius is 12 inches. The formula that's going to apply here is area equals pi r squared. So where we have the radius, we'll put in the number 12. And we'll just punch it on the calculator, pi r squared. To do that properly, you'll see pi 12 to the second power. And when you hit equals on the calculator, it will display 452.38, and then more digits. The next digit is actually 9, but let's round this to the nearest tenth. So this is the 8 will help us know whether the 3 stays the same or becomes a 4, and it would become a 4. The other thing to look at here is we're multiplying 12 inches times 12 inches. So the label would be square inches, so it's approximately equal to 452.4 square inches. This formula for circumference is pi times the diameter, or you could use 2 pi times the radius, since 2 times the radius is equal to the diameter. But we're given the radius, so we have to double it either way to get the diameter. So the diameter would be double 12, which would be 24 inches. So on the calculator, let me erase that. That should be inches. So we'll put in pi 24. And when you do pi 24, out comes 75.4, rounded off to the nearest tenth. 75.4, and that's inches. The number pi has no label, and the label for diameter is inches. So it's no label times inches means the label remains the same, inches. We're to find the area and the perimeter of the given triangle. The formula that we'll use for area is base times height divided by 2. Base times height divided by 2. The trick is to figure out what's the base and what's the height. If we try to use 30 for the base, we have a problem because we have to go to the opposite angle, which would be this 90-degree angle, and there's no given measurement here, so we can't use 30. We can use 18, and we go to the angle opposite 18, it would be this angle, and the shortest distance would be this 24. So if you thought of 18 as the base, you would do 18 times 24 divided by 2. You can also think of 24 as the base if you want to. The angle opposite 24 would be right here, and the distance to that is 18. So either way you set this up, you're going to do the product of 24 and 18. So we'll just write 24 times 18 divided by 2, and that would be the same as 12 times 18, which results in, put it in here, 12 times 18 is 216, and this is inches times inches, so it'll be square inches. And to find the perimeter of a triangle, we'll just use the idea that perimeter of a triangle is the 3 sides added together, a plus b plus c, and 24, 18, and 30 add up to 72. And you can add these numbers because the label is the same on all of them. It's inches, and the label doesn't change. So it's 72 inches. Okay, here we have a trapezoid, and we are going to find the area and the perimeter. I would advise you to do these calculations twice for each one because it's quite easy to make a mistake. Even though you may be using a calculator to do this, it's actually even easier to make a mistake with a calculator probably because you're just so confident that you've got it right. The formula is to find the average of the bases. B1 plus B2 divided by 2 stands for one base the sum of the two bases divided by 2, and that represents an average. So we want to find the average of 61.7 and 34.3. Be careful when you punch this in. If you go 34.3 plus 61.7 divided by 2, you will be doing half of 61.7 added to 34.3, and that's not what you want. You want 34.3 plus 61.7. You want that total, and you want that divided by 2. So you have to use one of two strategies here. You either do left parentheses 34.3 plus 61.7, right parentheses divided by 2, or you can go 34.3 plus 61.7 equals, and that'll give you the total of these two numbers, which will come out to be 96. They add up to 96. 34.3 and 61.7 add up to 96. And when you do 96 divided by 2, you should get 48. And then you just multiply it by the height. But what is the height here? Is it 20 or 24.5 or 17.3? It's the shortest distance between the segment of 61.7 and the 34.3. So it's this distance right here. So to sum it up, you'll do 61.7 plus 34.3, get that total, divide it by 2, and multiply it by 17.3. So it would look like 20, oops, wrong, 17.3 times 61.7 plus 34.3 divided by 2. And when you punch that all in, and that's the area. And maybe when I mention this is going to be centimeters here, this will be centimeters. So right here is where you get the centimeters times centimeters, which is square centimeters, which area always needs to be in some square units. I'll leave it to you to punch it in the calculator and verify that you should get 830.4 square centimeters. Perimeter is probably a little bit simpler. You're just going to add all these numbers, 20, 34.3, 24.5, and 61.7. So perimeter is the distance around. There's no handy-dandy formula for this other than you add the left side, the top, the right side, and the bottom. Add all 4 sides of the trapezoid. And when you do that, I'll trust you to punch them in. You get 140.5 centimeters. So this was 830.4 square centimeters. You might look at number 30 and say, no way, I can't do it. I don't know the base. But wait, it's an equilateral triangle, which means all sides are the same, 20 centimeters. We know the distance from this base to the opposite angle is 15.6. So the base is 20 and the height is 15.6. Area equals base times height divided by 2. So we're going to put in 20 centimeters times 15.6 centimeters divided by 2. And what do they do? 2 goes into 2 once and into 20 10 times. And we're going to remember that the multiply right rule will help us here. So we're going to move the decimal one place. When we're multiplying by 10, just move this decimal over one place. And the result is the answer of area being 156 square centimeters. The perimeter is 20, 20, and 20. All adds up to 60 centimeters. So we have this irregular shape, and the strategy for figuring out area and perimeter of an irregular shape is to split it into the types of figures that you can calculate area and perimeter for. So we're going to make a rectangle and a triangle by going up. I'll pick blue here. Should be pretty. Up from this location, I'm just going to point at this location to this location. So we know that from here to here would be the same distance as the base of the rectangle. So that's going to be 60. Altogether, it's 90, which means the shape that's left must be 30. So it's 30 feet just from here to here. So that's part of the mystery. Now we have to figure out what is it from this point where up to here is 35, but the rest of the way is 75. So what's this distance going to be? It's not what it looks like. This isn't drawn to scale very well, but this distance will be the whole distance, 75. Take away the 35, and 75 minus 35 is 40. So this would be 40. Let me just draw this triangle, just isolate this triangle. Again, not a great job of producing it, but this would be 30. I don't think I can fit it up there above that, so 50 and 40. We need that to figure out the area. The perimeter is pretty simple in this. It's going to be the sum of all the measurements that we were given, 90 plus 50 plus 35 plus 60 plus 75. The area, we have to calculate the area of this triangle, which is representing this one, the 30, 40, 50 triangle, and then the area of this rectangle, that is a 60 by 75. So we're going to do for area, 75 feet times 60 feet. I'm going to start over that. That's pretty rough. 75 times 60 feet plus the area of the triangle, which has a base of 40. We could call it a base of 40 and a height of 30. So that's going to be 40 times 30 divided by 2. So let me do those calculations. 75 feet times 60 feet is 4,500 square feet. And 40 times 30 is 1,200, divided by 2 is 600. And that's 40 feet times 30 feet, so that makes it square feet, as it should. And the total of 4,500 and 600 is 5,100. And it would be square feet. So the area is 5,100 square feet. So for perimeter, we're going to be adding the numbers that are given. We'll start here with this dimension, 75, and just go, we can go clockwise. 75 feet plus 90 feet plus 50 feet plus 35 feet plus 60 feet. And I greatly encourage you to write this down and then count. We have 1, 2, 3, 4, 5 numbers to add. 1, 2, 3, 4, 5. It's so easy to leave one out. So just don't do it. Make sure you count it up. And then when you add these numbers on your calculator, do it twice. And if you don't get the same answer each time, do it again. And keep doing it until you get the same answer 2 or 3 times. It's such an easy problem that you must get it right. Okay, I punched that in on a calculator 2 times, and I was very happy to see the same answer come up both times, so I'm pretty confident that it's the right answer. But if you get a different answer, just try it over and over again, and if you get it the same answer 3 times, you could probably come into class and say, you had the wrong answer, Mr. Chaffinch. But I do believe it's 310 feet. So that concludes our practice test. Your actual test will be similar to, but not congruent to, this test.